Hey guys, so next topic in our logarithms unit, 8.4, is called logarithmic equations. So I'm going to say this is an extension from topic 7.3, which was exponential equations. So the type of equations we saw in chapter 3 was like if you had 25 to the x plus 2 equals 125 to the 4x plus 1. Now the way we solved those was like 25 is equal to 5 squared to the x plus 2. 125 the same thing as 5 cubed to the 4x plus 1. And then so that would be 5 to the 2x plus 4 equals 5 to the 12x plus 3. And these guys both have the base 5, so therefore 2x plus 4 equals 12x plus 3. And then just isolate for x now. 10x equals 1, so 1/10 equals x. Okay, so these type of equations were ones that we did in chapter 7. Now, hopefully what you can see here, guys, that these questions only worked because 125 and 25 both could be written as base 5 numbers. Okay, well, what happens if you can't convert both of those guys to the same base? And like, so something as simple as like 5 to the x minus 4 equals 6 to the 4 plus 2x. Well, so this type of equation like that, we couldn't do it in the same way because 5 and 6, you cannot convert those guys to a common base. Okay, so we need to kind of figure out a few new techniques to be able to deal with questions like these ones over here. So, guys, a logarithmic equation is going to be just an equation with a logarithm in it where we have to solve for x. So this is the most basic example. This is pretty simple because like log base 7 of x plus 5 equals log base 7 of 12. These guys are both log base 7. Okay, so if they're both log base 7, doesn't it follow that x plus 5 must equal 12? And therefore x must equal 7 for that to happen there. Okay, so that's how equation like this works. More complex is something like this. We have log base 2 of x plus 4 equals log base 2 of x. Now, what we studied in our last topic, in our laws of logarithms question, we saw questions like this. So what we have is our product law of logarithms. So log base b of m times n is the same thing as log base b of m plus log base b of n, like this. So really what we're doing here is that we have a situation like this where we're adding two logarithms, and so we can combine them using multiplication. So this is the same thing as log base 2 of x plus 4 times x equals 5. So these are the kind of the types we're going to see most often. We have a logarithm on one side of the equation equals a number on the other. Now what we're going to do this is we're going to solve by converting this into exponential form. So what this logarithms equation means is that 2 to the power of 5, this is the base, this is the exponent, this is the argument here, is x plus 4 times x. 2 to the power of 5 is 32. X plus 4 times x is x squared plus 4x. And now this becomes like a math 20 question. We have to be able to solve this quadratic. We're going to set one side equal to 0. And we can solve this guy by factoring now. So this is going to factor to x plus 8 and x minus 4. So therefore, either x plus 8 equals 0, that means x equals negative 8, or x minus 4 equals 0, and x equals positive 4. Okay. Now the last thing we need to do here is like we said in our last section, logarithmic functions or logarithmic expressions have restrictions. So in other words, the argument can never be a negative number. It has to be positive, greater than 0. Okay. So, but if I put in a negative 8 plus 4 is negative 4. So I'm going to have a negative answer over here. We need to exclude this solution here because it makes the argument of our logarithms negative. So this is going to be an extraneous solution. 4 is good. log base 2 of 4 plus 4 is 8, so 8's positive. Log base 2 of 4, yeah, that's good as well. So x equals 4 is the only solution for this equation over here. Okay, C, very similar idea over here. A couple ways we could do this question, and here's the way I'm going to choose to do it. I'm going to convert this guy into exponential form right away. So we have 2 squared equals the square root of x squared minus 6x. 2 squared is 4. Okay, so now we're left with a radical equation here, and the way we solve that is we just square both sides of the equation, and it's going to get rid of the square root on the right-hand side. Okay, similar to what we did in the last one, we're going to solve this one by factoring. This guy factors to x minus 8 times x plus 2. So either x minus 8 equals 0, and that would mean x equals 8, or x plus 2 equals 0, and that means x equals negative 2. Now, checking these answers over here, log base 2 of 8 squared minus 6x. 8 squared is 64. 6 times 8 is 48. 64 minus 48 is 16. Okay, now really what we're checking for is making sure that this whole part's going to be positive, and it is. Okay, so just let's check this fully. Log base 2 square root of 16 is 4, and log base 2 of 4 does equal 2, and 2 does indeed equal 2. So this solution is good. Checking our negative 2, this one is also going to work. 4 plus 12 is 16, square root of 16 is 4, and again 2 does equal 2. So in this case, both these solutions work. So we have x equals 8 and negative 2, and that is the solution for this equation over here. Okay, example D over here. I'm going to show you kind of, I think the easiest way to do this question is to use our power law for logarithms. So our power law again was log base b of m to the n is n log base b of m. So in this case, the 5 can come down in front. And then I'm going to divide both sides by 5. Oops, that was an x squared, not an x cubed. Okay, so we have a logarithm equals a number now. We're going to convert to exponential. That means 3 to the power of 2 is x squared minus 8x. 3 squared is 9. Solve by factoring. Okay. All right, so for both of these guys, I'm just going to confirm that the argument is going to be positive for both of those. So if I put like 9 squared minus 8 times 9, this is 81 minus 72 equals 9, so that one does work. And if I check my negative 1 solution, negative 1 squared minus 8 times negative 1 is 1 plus 8, also equals 9. Okay, so what we're checking for is that this part here can't be negative. Okay, and so when I check both solutions, I got positive answers for both of them. That means these solutions are both going to work. Okay, so for example 2, so example 2a is a question that was covered in chapter 7. 16 and 8 are both base 2. 16 is equal to 2 to the 4th. 8 equals 2 cubed. So we're left with 2 to the 4x minus 8. equals 2 to the 3x. Both the bases are the same, so therefore the exponents must be the same as well. And we get x equals 8. Okay, nothing necessary to check for a question like this. Example B is a little bit different because like 3 and 8, we can't convert these numbers into a common base. Okay, so again, the purpose of a logarithm is to isolate for an exponent. Okay, so if this is my base, this is my exponent, this is my argument or my answer. If I convert this into logarithmic form, this is the same thing as log base 3 of 8 equals x. And now I can just go to my calculator. And guys, this is not going to be an exact value. This is going to be a rounded value coming up. So math, log base 3 of 8. Answer is, there's my answer over there. Sound good? I'm going to show you one more way of doing this question. And I'm going to suggest that we do this question from this method from now on, because this method was not going to work for more complicated questions, but the second method will. So the second method is, we are going to take the log of both sides of this equation. So I'm going to go log on this side, log on this side over here. Okay. Now this is log base 10 on both sides of the equation. Okay. Now it's base 10 because all calculators have like a log button, not just log base 10. So this is going to be a convenient base to be able to take. Now what we're going to do is we have log of 3 to the x. If we use our power law, we can bring the x down in front and make it x log 3 equals log 8. Now divide both sides by log 3. Like this, okay? And so the same thing, if I just go log 8 divided by log 3, I'm getting the exact same thing that I had before, the exact same answers, okay? All right, guys, I'm going to have to pause this video right now, and I will finish up the rest of these examples in the next video. See you in 1 sec.